Under the ice, off Antarctica, something falls that shouldn't be able to kill anything at all. It isn't snow. It isn't a storm. It's the ocean itself, turning against everything living beneath it. Scientists call it a Brinicle, a finger of ice that grows downward from the underside of the sea ice, reaching for the seafloor. In 2011, a BBC film crew became the first people ever to capture one forming on camera. What they filmed looked less like weather and more like an execution. This is the story of the ocean's strangest kind of rain, a rain made of ice, one that spreads across the seafloor and freezes everything it touches. Welcome back to the Abyss Report. This phenomenon was first filmed in the frozen sea of McMurdo Sound in Antarctica's Ross Archipelago, close to Little Razorback Island, not far from McMurdo Station and New Zealand's Scott Base. Here, a thick sheet of sea ice covers the water year-round, sealing in an entire ecosystem beneath it. This part of Antarctica has been studied by polar scientists for decades, precisely because it stays this stable. Beneath that ice, the water stays remarkably calm and remarkably cold all year long. It's here, in this quiet, frozen world, that something starts to grow downward out of the ice itself. To understand a brinicle, you have to understand what happens when seawater freezes. Freezing seawater doesn't make clean ice. It makes something closer to a frozen sponge, riddled with tiny channels. As the ice forms, it pushes salt out of itself, concentrating it into those channels, a process called brine rejection. That expelled brine is far saltier and far colder than the seawater around it. And because it's so cold and so salty, it's also far denser, heavy enough to sink. So it does. Drop by drop, it drains downward out of the sea ice into the ocean below. As that sinking brine drops through slightly warmer seawater, it does something remarkable. It freezes the water around itself. A thin sheath of ice begins forming around the falling brine, like a straw growing downward through the water. Inside that sheath, more freezing brine keeps draining down, extending the structure further with every passing minute. The result is an icy, hollow tube descending from the underside of the sea ice toward the seafloor below. Researchers call it a brinicle, but most people who've seen one just call it the finger of death. It looks fragile. It isn't. Everything about it is built entirely from cold and salt. If conditions hold long enough, the brinicle keeps descending until it finally reaches the bottom. Where it meets the seafloor, the icy tube ruptures, and the freezing brine spreads outward instead of down. A thin, spreading web of ice crawls across the seabed, freezing the water immediately above the mud. Any slow-moving animal caught inside that web has no way to escape it in time. Sea urchins and starfish are the most common casualties. Both are common on the seafloor, and neither can move quickly. Within minutes, they're locked in place, encased in ice exactly where they were standing. Underneath an especially active brinicle, something even stranger can form on the seafloor. Pools of pure brine collect in shallow depressions, water so cold and salty that almost nothing can survive inside them. Polar researchers have a name for these: black pools of death. They're often perfectly clear, which makes what's inside them even harder to look at. The skeletons of animals that wandered in and never wandered back out, still sitting exactly where they died. It's one of the strangest graveyards in the entire ocean. A brinicle isn't a slow event. Once conditions are right, it can move fast. Some have been recorded growing several meters in a single day. One documented case in the scientific literature recorded a single brinicle stretching to 6 meters before it stopped. That's the height of a 2-story building built entirely out of falling salt and ice in under 24 hours. And then, just as suddenly, it can stop, the moment conditions above the ice shift even slightly. None of this happens without Antarctica's brutal temperature gap between air and sea. In winter, the air above the ice can fall below -20 degrees Celsius, sometimes far colder. The seawater just beneath that ice, meanwhile, holds steady at close to -2 degrees, dramatically warmer than the air above it. That gap is what drives the entire process, pulling heat out of the sea ice fast enough to keep concentrating brine and pushing it downward. Without that extreme imbalance, none of this would ever begin to form. Brinicles had been theorized since the 1960s, but almost nobody had actually filmed one forming. They're rare, they're unpredictable, and they only happen beneath one of the most hostile diving environments on Earth. To capture one, a film crew built custom time-lapse rigs and lowered them beneath the Antarctic ice for days at a time. Divers worked in water just below freezing, waiting for a brinicle that might never actually appear. When one finally did, it became the first time-lapse footage of a brinicle forming ever recorded. Total darkness, extreme cold, and years of patience for a few minutes of footage that changed how people saw this phenomenon entirely. Brinicles aren't unique to Antarctica either. Similar formations have been spotted in the Arctic, off the coasts of northern Canada, Greenland, and Siberia. But Antarctica's thick, stable ice shelves make conditions here far more reliable, which is exactly why almost every documented brinicle traces back to this one region. Some researchers even study brinicles as a rough analog for icy moons like Europa, where similar freezing processes might occur beneath alien oceans. A phenomenon that looks like something out of a horror film, quietly reshaping how scientists think about life at the edges of survivable cold. Somewhere under the Antarctic ice right now, a finger of frozen salt may be growing downward in total silence. It isn't rare because it's violent. It isn't famous because it's fast. It's remarkable because for most of human history, nobody even knew the ocean could rain like this at all. Subscribe to the Abyss Report. We go back down next week. See you in the deep.